G'day. Today we're diving into the fascinating world of binary. Ever wondered how computers communicate and process information? Well, it all starts with binary. So, what exactly is binary? Now, don't worry if it sounds a bit tricky at first. We're going to break it down into easy to understand bits. Binary is a counting system, much like the decimal system we're familiar with. In decimal, we have 10 digits from 0 to 9, but in binary, it's different. Binary, stemming from the Latin root bi, meaning 2, consists of only 2 digits, 0 and 1. Think about how the decimal system works. We start with 0, go through all the digits until 9, then cycle back to 0 and add a digit in the next place value. In binary, we follow a similar pattern, but with only zeros and ones. Our place values also change. Instead of multiples of 10, in binary it's multiples of 2. So the place values are 1, 2, 4, 8, 16, and so on. This nifty chart helps us to see how decimal and binary numbers work side by side. Pretty neat, hey? Now let's dive a little deeper into how computers use binary. Imagine you have a super fast light switch. When it's on, 1, the computer understands yes. And when it's off, 0, it understands no. Computers have millions of these tiny switches, making them super quick at understanding things. When a computer sees a 1 in its code, it activates a gate or a switch. 0 means the switch is turned off. Computers consist of millions of these switches per square millimeter, enabling them to process information swiftly. In digital systems, every set of zeros and ones is called a bit. More bits mean more complex information. For instance, with 8 bits we can represent the numbers from 0 to 255. With 32 bits we can represent huge numbers. That's over 4 billion possibilities. That's B for billions. But binary isn't just for numbers. Oh no, it's also how computers talk about letters, pictures, and even sounds. Let's see how computers use binary to represent text. Each character is assigned a unique binary code, known as ASCII or Unicode. Similarly, images are made up of pixels, with each color represented by binary numbers. Audio too can be represented as a waveform, which is then converted into binary. Ultimately, while we don't directly use binary, it's the foundation of all digital communication. Hardware converts the binary into formats we can understand, like text, images and audio. Binary is like the secret language of computers. It's how they talk to each other and to us. And that's the essence of binary. It's the language of computers, enabling them to process and communicate information in the digital world using zeros and ones.